Okay, so again, it doesn't matter which compass you have, but these are going to be the constructions that we're doing today. First one, equilateral triangle. It doesn't matter the length of the line you start off with, but you draw a line segment, whatever length you want, and then you are going to have to move your compass to be the length of that piece, whether you're using this compass or using this compass, right? And when you do that, you now have the length of one side. To make it equilateral, you're just swinging an arc from each of those points to the same side, and that'll give you your third point. So it doesn't matter if you use that one or if we were to use this compass and swing our arc like so. Again, they both should give you, oops, I'm a little off there. They should both give you your intersection in the same place. So now, if you connect that third vertex, you have yourself an equilateral triangle. And that was one way to do an equilateral triangle. But then you could also do an equilateral triangle in a circle. So, same thing, equilateral triangle in a circle. So, in order to do an equilateral triangle in a circle, and I'll do this twice, once with each compass, I'm going to take a compass, and we've done one construction that's very similar to this before. I'm going to mark a point to be the center of my circle. I am then going to take my compass, put it on that point, and swing a circle around that point. I am not going to change the stand of my compass. I'm going to go to a random point on the circle, and I'm going to use that same setting to mark off distances around the circle. And I'm going to keep going with that same measurement all the way around the circle. So in the end, you should end up having 6 marks that are equally spaced. And the very first time we did constructions, we did this and we created a little flower. I don't know if you guys remember that. But instead of just stopping with one little mark like this, we actually created an entire arc going all the way through the circle. Well, it's the same exact construction steps as that little flower, that 6-petal flower, except we're not swinging the arcs all the way through the circle. We're just marking off that equal distance all the way around. So now we have 6 equally spaced marks around the circle. Well, if we connect every other point, we end up with an equilateral triangle. So if we connect those 2 points, those 2 points, and these 2 points, so we connected every other point, we'd have an equilateral triangle. Yeah. So again, I'll do that one more time with the other compass. So if I had a point to start at, is it warmer in this classroom?
Yeah.
Okay. I thought maybe it's just because I had to go off campus and basically ran back to the classroom that I was like really warm, but I'm starting to think it's just this classroom. You think it's cold in here? Who thinks it's hot?
I think it's warm. It's not like hot.
All right, who thinks it's warm?
I think it's nice.
It's neutral in here.
Yeah. Like the desks are nice and cool. Mine's definitely warm.
So it's probably the humidity is way up again and the air's probably nice. All right. All right, I'm going to pick a random point again. And again, do the same exact thing. So going around the circle, just marking out that same distance that I used to do the circle. Until I have 6 equally spaced marks, and then connect every other mark so that we have an isosceles triangle. Now, the next construction is equilateral. My bad. Equilateral triangle. An equilateral triangle is isosceles, but this one does have all sides equal, so it's equilateral. Now, the next construction is actually the exact same steps. exact same steps. So we are going to create, for the next construction, a regular hexagon in a circle. Well, how many vertices does a hexagon have? 6, right? Pentagon's 5, hexagon 6. Now, on the last construction, how many equally spaced marks did we actually make in the circle? 6. So instead of connecting every other point, if we connect every point consecutively, we should end up with a regular hexagon. So I'm just going to do this one once because it's the same construction that we just did. So I'm going to start off with a point. I'm going to draw a circle with my compass. Whoops. Around that point. Then I'm going to pick a random point. Again, I'm going to move my compass to mark off equally spaced pieces with that same measurement that I created the circle with. So I should end up with 6 equally spaced. Again, if it's perfectly accurate, it'll go right back to where we started. So we have 6 equally spaced marks. Take a straight edge, line it up, and connect every single consecutive point. And when we do so, we end up with a regular hexagon. So these first 3 aren't difficult constructions. All right, you're using kind of the same ideas and same steps.
I don't know how to tell if it's real.
Now, the next one will be a little bit different, but we are still talking about creating something in a circle. This time we're going to do a square in a circle. And one of the properties that we're going to do here actually will help us out in our next section, because we're going to get into a lot of stuff with circles in the next unit. But this one, we're going to talk about a, whoops, I almost put regular. Well, I guess it is a regular. It's a regular quadrilateral, or it's a square. A square in a circle. So, again, I'll do this one twice. So, let me move this one out of the way. We're going to start off with a point. We're going to draw a circle around that point. Make sure it doesn't run into my words over there. Now, we can do this a couple different ways with a square.
Can I guess something?
Go for it.
You do the 6 little thingy marks, right?
No.
Then you would only connect 4 of them.
No, it doesn't work that way. Let's try though. All right. So for a square, we're actually going to start off with a diagonal, or a diameter. But our diameter for the circle will act as a diagonal in the square. So we have to make sure we draw this diameter through the center point of the circle. All right? So it's going to be through the center point of the circle. Now, once you have that diameter, that will act as one diagonal in our square. Our square has to have equal length diagonals, right? Because it's a rectangle. And they have to be perpendicular because it's also a rhombus. Well, as long as we're using diameters, we know that they're going to be the exact same length. So we have to do one more diameter. But in order to figure out where that diameter is going to go, we need to make it perpendicular to the first one we drew. The way that we do that, we're going to have to extend our compass saying just a little bit. As long as it's longer than what we had the original saying on, that's fine. And we're going to swing an arc, and it could just be to one side. It doesn't have to be to both sides. You could do both if you want, but I'm just going to swing it to one. All right. And once you have that point, from here through there should be a perpendicular line. So this goes back to creating a perpendicular bisector. People long time ago.
Like someone had to have
These are
nothing
ancient.
to do in their life. And just sit there and be like, let's go ahead and produce kids centuries later and be like, this makes
You know, they didn't have a computer back then. They didn't even have, you know, they might not have had things to measure actual like actual rulers. They came up with these things. Nah, they probably had rulers, but
So you're saying that this stuff you can honestly
this is ancient. Constructions are ancient.
believe in them because someone created it. You can say they're wrong.
No. All right. This point. So from each end of the diameter that we had drawn, we swung an arc that was a little bit longer. We had to change the setting on our compass, so that was a little bit longer, so that it would go somewhere offline and create an intersection. Once you did that, you connected that point through the center. So now we have a perpendicular line that's for each one of these arcs. Those two are the same length. Yes. Yeah. Those have to be equal. I do not. All right. So then we just connect the ends. So connect the ends of each of those diagonals, and we have ourselves a square. Now, I'm going to do it one more time with the other compass. So, put a point, draw a circle. Whoops.
I've never heard of
Are you working on your TFA project?
So, we have our circle. Draw a diameter through the circle. From each of those points, again, I can't leave my setting where it is because the intersection would be right at that same point. So again, I have to make it a little bit bigger. And last time, again, I said I could go to one side, or if you want to, you could go to both sides. It doesn't matter. If you go to both sides, your line might be a little bit more accurate. All you need is 2 points to make a straight line, though, so you don't have to have the second set of intersections, because you already have the center of the circle that has to be on this line. But again, if you want a third point, all three of them should be in a line, so that you can draw that line. And now we have two perpendicular diameters, which will act as our two diagonals in the square. So then we connect the points. Oh, that was a horrible line that I just drew. It's totally crooked. Try to draw them as straight as you can with your straight edge. That one is definitely crooked, but it still looks pretty good. Again, that is a square in a circle. Now, so we've done a equilateral triangle two different ways. We've done a hexagon, and we've done a square. The last one of the constructions that we need to talk about is a tangent line. Now, we have not defined a tangent line yet. Tangent actually comes up in the next section. So, does anybody in this class know what a tangent line is?
Didn't know what it was.
You did know what it was. Don't remember. All right. So,
familiar.
tangent line is a line that intersects a circle at exactly one point called the point of tangency. Oops. Tangency. Is it CY? I can't remember how to spell tangency. Tangent C? I can't remember. It's either an E or a Y. I forget. I want it to be correct, so let me double check it real fast. Point of tangent C. It's a Y. All right. So we're going to make a tangent line on a circle. Now, just as a little diagram here, before I do the construction, just so you understand what it is. So there's my circle. A tangent line would look something like this. And there are certain properties that we're going to go over in the next chapter. And the most important one for what we're going to do here is that if you drew a radius to the point of tangency, it is going to make a right angle. That's what our construction is going to be based on. The fact that if you were to draw a radius to that point of tangency, it has to create a right angle. All right. So now, how can we do this? We can take our compass. We're going to take it, draw a point. We're going to draw a circle. Now, if you just want to pick a random point to draw a point of tangency to, we can. So I'm going to draw a point right there. I'm going to draw my radius out to that point. Now, there are several different ways that you can do this next step. What I recommend doing, since we already have the setting in our compass, again, there is more than one way that we can draw a perpendicular line through this point. One of the easiest ways would be to continue this line that we just drew all the way out, so that's at least double the length that we currently have, so that the setting that we have on our compass, we can mark it off again. Now, the reason why I'm doing that is because now this point is equidistant from these two. That means that this point is going to be on a line that would be the perpendicular bisector of this segment that we just made. So, if we go from both of these 2 points, so again, now we're going to use these 2 points here, this point and this point, and we need to change our compass setting so it's a little bit longer. Same way that we did on the last one, draw an arc from each one. It could just be to one side. If you want to do to both sides, that's fine. But from both of those points that I circled in pink, again, you don't have to do both sides. You could just choose to do one because all you need is 2 points to draw a line. So we could have just used these two. But again, all 3 of these would have to be on that same line. So it's just to help with the accuracy of it. I'm lining all 3 of those up the best I can. And that is a tangent line. Because that is a perpendicular line to that radius, and it's going through a point of tangency. Now, like I said, there's more than one correct way to do that one. I highly doubt you'd ever see anything like that on the FSA because different books do this one different ways. So there's not one way to do this, which means that it'd be a very hard question for them to ask on the FSA. So out of all these constructions, this one is the least likely construction to be on the FSA. All right. Again, the other ones that we did today, not so bad, not too difficult. The steps are very similar on a lot of them. Those are all the constructions that we needed to cover. All right. Any questions on the ones that we did today? No? All right.